Okay, this is your 4.2 video, and this is called Angle Relationships and Triangles, and this is where we get more into the theorems that have to do about triangles, which is going to lead us to more proofs. So this is where our proofs come back pretty heavy. So this is a really important section for us here. Okay, the first proof that we have in this chapter is one of the most important ones. You'll use it all year long, is the triangle sum theorem, and it just says that the angles in a triangle have to equal 180. And so you know that already, but now we have a name to put with it. And you can abbreviate when you go to use this in a proof. You can say triangle sum theorem like this. Okay, our proofs are getting a little more in depth. So this one we're about to use is going to need what's called an auxiliary line. And that is a line that you draw in yourself, and that helps you get the proof. You can just, it's kind of like multiplying by 1. You didn't do anything, but it helps you prove your point. So that's what we're doing here. My dog is driving me crazy. Okay, so this is the proof for triangle Sachi, sit down. Sit down. She listens to me about as well as y'all do. Okay, so here, this diagram right here is the only thing that was given to us. This triangle ABC with angles 1, 2, and 3. I drew in line L, which added these angles 4 and 5 to help us in this proof. Okay, so I want to prove that the angles 1, 2, and 3 add up to 180. Now, this is the triangle sum proof, so I can't just say, oh yeah, triangle sum. Okay? Alright, so let's look at this here. Now, the first thing that we normally do is that we put our given down. But in this case, the given is like, hey, here's a picture. So what we did instead for our first step is we're going to tell people that I drew in line L, and I drew him in purposely to be parallel to AC. Okay? Now, whatever you want to call this, it's technically called the parallel postulate because we're using this from what we learned about parallel lines to make sure we know they're parallel. If you had called that auxiliary line or anything like that, I'm not going to yell at you for that, but that's technically what would go there because I made the line be parallel to AC. Okay, you can see next that we're using the alternate interior angles theorem. So here you have a couple of choices because if these lines are parallel, you've got two transversals. You've got this one and this one. So look a step down in the proof and you can see step 3, we're using 1 and 4. So that must mean they want us to use angle 1 and 4 first. So we're going to say 1's congruent to 4 by the alternate interior angles theorem. Then if those angles are congruent, then they are also equal. Anytime we go from congruent to equal, we're going to use definition of congruent angles. That's another one that we use very often. You can see we're going right back to alternate interior angles theorem. So if we use 1 and 4 already, they must be asking for us to use 3 and 5. I hope you can see alternate interior angles there. So angle 3 must be congruent to angle 5 because they're also alternate interior. Same steps yet again. If 3 is congruent to 5, then 3 is equal to 5 by definition of congruent angles. If I were doing this proof myself, it would be perfectly acceptable to put 1's congruent to 4, 3's congruent to 5 right next to it, 1's equal to 4, 3 is equal to 5 right next to it. If you're using the same reasons, then you can put them in the same step. So if you wanted to do that, if you were doing this on your own, you would go for it. You would be just fine. Okay, so this one is a double reason all in one. It says angle addition postulate and definition of a straight angle. Now we know from chapter 1 that a straight angle is a straight flat line that adds up to 180. So you can see that's what we have going on here. Where if we were to add the measure of angle 4 plus the measure of angle 2 plus the measure of angle 5, that would have to equal 180. So double reasons here. 1, because we're adding angles together. Angle addition postulate. You remember that from chapter 1. Piece plus piece is the whole thing. Only now I have 3 pieces. Piece plus piece plus piece. And how much is the whole thing? Well, it's got to be 180 degrees because that is a straight angle, so it has to equal 180. Okay, last step. We are still going to put our proof down here. Okay. So how can we go from 4 plus 2 plus 5 to 1 plus 2 plus 3? Well, that comes from these steps over here. I can swap out 3 and 5, and I can swap out 1 and 4. And what do we call that when we swap out? That would be substitution. Okay, you want to use substitution because it's over addition, so transitive would not be a good idea here. Substitution would be much better. Okay, reread through that proof if it didn't make too much sense to you because it's an important one. All right, example 1. The map of France commonly used in the 1600s was significantly revised as a result of the Triangulation Land Survey. The diagram shows part of the survey land map. Use the diagram to find all the missing angle measures. Okay, so this is kind of hard to see, but the only thing given to us is these two arc marks right here telling us NKM is congruent to KMJ. All right, so let's start on this side and we'll work our way around this way. So if this is 48 and this is 88, I want to know how much the measure of angle NKM is. And these three form a triangle, and I already learned by the triangle sum theorem that has to be 180. So I'm going to go ahead and just write this in so you don't forget when you're doing this on your own. They have to equal 180. So that means there are 44 degrees left to spare for NKM. Okay, I'm going to go ahead and also put that we use the triangle sum theorem here, just so we don't forget. Okay, moving on around the side, so that would mean the measure of angle KMJ is also 44 degrees because it's given that it's congruent to angle NKM. Okay. So, moving on up the side here, so let's go for measure of angle KJM. Same story as this triangle. If this is 44 and this is 104, they have to equal 180 because they equal a triangle. So I've already used 104 degrees. I've already used 44 degrees. Let's tap this in. So that is 32 degrees. Okay, now there are two ways that we can get this right here, and it doesn't matter to me which way you get there. I think the easiest way would be to use this straight angle right here because we just used that in the last proof, so it's kind of fresh on our mind. So this whole thing right here has to be 180, so I can say measure of angle L, oops, wrong way, LKJ. I have already used 104 and I've already used 44. Looky there, that looks strikingly similar. I bet that ends up being 32 degrees as well. Okay. Now what I was saying, the other way that you could use it would take 2 steps, but if you realized over here that these two are congruent, I hope maybe some of you recognize that that would be parallel lines cut by a transversal. So if these alternate interior angles are congruent, these lines must have been parallel. So if these lines are parallel, these alternate interior angles would be congruent. If you wanted to prove that, you would have to say, do alternate interior angles to prove that the lines are parallel. Then you'd have to use converse to prove the lines are parallel. Then you could use regular alternate interior to prove that. So it would be a 2-step where this one would be angle addition postulate, and it would be definition of a straight angle, just like we used on that theorem a second ago. So either one you want to. And then last step, measure of angle KLJ. Same thing with that triangle sum theorem here that we used here and here. It has to be 180. I've already used 70. I've already used 32. So I have 78 degrees left using the triangle sum theorem. Okay, very good. Okay, a corollary is a theorem whose proof follows directly from another theorem. So we've talked about postulates just are true because they're true. You just have to know it. There's no proof for it, anything like that. A theorem is a statement that you could actually work through a proof and tell somebody why it's true, because this. Corollary is similar to that. It's a type of theorem, only you need a one specific theorem, and then this works off of it. So we have two corollaries here for this section, and you'll kind of see what I mean in a second. So the first one is 422, and it says the acute angles of a right triangle are complementary. And we know complementary means they add up to 90. So this one comes off of the triangle sum theorem. If all three angles have to add up to 180, and you've already used 90 for that right angle, then it just makes sense that the other two have to add up to 90. So this is why this is a corollary, because it's based off of triangle sum theorem right there. Okay. The other one is something we talked about just briefly on the 4-1 video. The measures of each angle of an equal angular triangle have to be 60 degrees. So this also follows from the triangle sum theorem. If it has to be 180, they all have to be the same, then it has no choice but to be 60, 60, 60. Okay, so these are corollaries because they follow directly from the triangle sum theorem. All right, let's look at this example here. One of the acute angles in a right triangle measures 2x. What is the measure of the other acute angle? Okay, so we're talking about angles of a right triangle, so we're going to be using that corollary 422 that says the two angles have to add up to 90. Okay, so if they have to add up to 90, this is like that complementary supplementary thing we did in chapter 1. If one of them's 2x, the other one's just going to be 90 minus 2x. I hope you remember that complement of a supplement and all that stuff we did in chapter 1. If you start with a algebraic expression, you're going to end with an algebraic expression. If I had told you one of the angles is 37, then you would end with a measure because you would just type it in your calculator. But if I give you an x, your answer is going to have an x in it. Okay. Moving on, more vocabulary. We're going to talk about interior and exterior of a triangle, and that kind of makes sense. Interior is anything inside the triangle. So in this case, 1, 2, and 3 are interior angles of a triangle. In this picture, the only exterior angle is angle 4. I could just as easily extend this here and call this angle 5. He would be exterior. I could extend this, and he would be angle 6. He would be exterior, but the only one pictured is 4. Okay, so that makes sense, interior, exterior. The new thing that might not make sense is what's called remote interior angles. So what that is you have one exterior angle, we'll go with 4 here. Remote interior angles are the angles that are inside the triangle that do not touch 3. Think about remote as in like a TV remote. You don't touch the TV with the remote. You sit on the couch and you press it from afar. So angle 1 and angle 2 are remote interior angles to angle 4. Remote because they're far away, and then interior because they're on the inside of the triangle. Okay? 3 is not remote interior because it's touching 4. It's not far away. Okay, so the exterior angle theorem, is why we need to know this, says that the measure of an exterior angle of a triangle is equal to the sum of the remote interior. So all that says is that measure of angle 4 is equal to 1 plus 2 together. Again, that's based on the fact that a linear pair has to add up to 180 and the angles in a triangle have to add up to 180. So that's why we can kind of substitute 1 plus 2 in for 3. That's where that came from. Okay, so let's do the proof for this one right here, and then we'll talk about third angles theorem. So you can use, it tells you right here, use exterior angles theorem to prove this, and we just learned that. That means the outside angle is equal to the two remote interior angles added together. Outside is equal to inside. This is like 4 is equal to 1 plus 2 in the previous problem. Okay, once you get it set up, then it's just algebra from here. So let's combine like terms. Okay, and then let's move the 2x this way and the 60 this way. 3x is equal to 78. So x is equal to 26. It didn't say find x. It said to find the measure of the angle B So I'm going to plug that in here. 2 times 26 plus 3 be 55, right? Yeah, 55. Good. So we can make sure that that is 55 degrees there. Okay, so the important thing here is the exterior angles theorem. Outside equals the two remote interiors added together. Okay, last theorem in this section is really an important one. It's called the third angles theorem, so look on your vocabulary chart. This theorem will get confused with another theorem that we're going to learn later in the chapter. So if you really learn this one well now, you won't get it confused. But this is one of those like transitive and substitution where people get them mixed up all the time. Okay, this one says if two angles in one triangle are congruent to two angles in another triangle. So here, this angle is congruent here, and this angle is congruent here. That says that there is no choice but for these third angles to be congruent to one another. This is also based on the triangle sum theorem, because think about it in easy terms. Let's say if this were 100, then this has to be 100, right? If this were 10, then this has to be 10. Okay, so think about just this triangle by itself. If this is 10 and this is 100, how much does this one have to be? It has to be 70. And then this one by itself. If this is 100 and this is 10, how much does this have to be? Has to be 70. So the third angles have no choice but to be congruent, because this has to equal 180 and this has to equal 180. So that's why we call this the third angles theorem. If two are already congruent, then the third has to follow suit. Okay, super important for later. Alright, find the measure of angle K. I'm guessing this meant to say, and the measure of angle J using the third angles theorem. Okay, we see this a lot with this overlapping triangles. You'll see this more and more coming up. The very first thing you want to do anytime you have an overlapping figure is redraw this totally separate, not overlapping. Still facing the same direction, still labeled appropriately, but just not overlapping. That way, it's much easier to see what's going on. When this is separated, you can clearly see third angles theorem. These two are congruent, these two are congruent. Therefore, the third angles theorem says angle K has to be congruent to angle J. So I can set them equal to each other. 4y squared has to be equal to 6y squared minus 40. And then I'm just going to solve. Negative 2y squared is equal to negative 40. Y squared is equal to 20. Take your square root. Looky there, more square roots. Hope you practiced. That would be 2 on the square root of 5. Okay, you don't have to break that down as fast as I did. Just a quick recap. Remember, you're doing your prom thing. This is 2 and 10. This is 2 and 5. These 2's have dates to the prom, so they come outside the house. This 5 is lonely, so he stays inside the house. So 2 on the square root of 5. Okay, see you tomorrow.